Okay, so for embedded C programming here, we need to know, or we need to write the first instruction as hash include reg51.h. Okay, that is the header file for embedded C. Okay, now after that, here also we need to write the main program, and in the main program we need to first set the SCON register. Then we need to set the TMOD register and PH1 data, and after that we need to start the timer by making PR1 equal to 1. Okay, and we need to wait unless and until the TI becomes 0. Okay, so this is the just like in assembly language programming what we have done, here also we need to do the same. Okay, now here what we will assume, previously we have taken the baud rate as 9600. Okay, so for this program what we will do, we will take the baud rate of 4800. Okay, so according to that, here we will set the timer, that is TMOD register. So for TMOD register, here what we need to do, for upper 4 bits which are for timer 1, these bits will be, first gate is 0, then C oblique T bar is 0, then we need to take for auto reload mode we need to take mode 2, so the bits are 1 0. Okay, and for timer 0 the bits will be 0 0 0 0. So here overall the count which we need to store in TMOD will be 28. Okay, now for PH1, here what we need to do, just like in the previous lecture I have told you that for serial communication, where when we are setting the baud rate, here oscillator frequency which is getting divided by 12 for timers, the same frequency or this whatever the frequency f which we are getting, we need to divide it by 32. Okay, so after that we are getting the count as 28800 hertz. Okay, that is the frequency which is used for serial communication. Okay, now if we want to set the baud rate for 9600, which is compatible with other peripherals, so here we need to divide it with 28800, we need to divide it by 3, so we are getting the baud rate of 9600. Okay, when we are dividing it by 3. Similarly, if we are dividing it by 6, so 28800, when we are dividing it by 6, we are getting the baud rate of 4800. Okay, so here what we need to do, we need to divide this count 28800 by 6, so that we are getting the count in the TH1. So here we need to load the TH1 with either -6 or we need to add with FA. Okay, why FA? Because 256 minus 6, we are getting the value as 250, and when we convert this 250 into hex, then it becomes FA. So we will take here 250, when we are converting it into hex, we are getting FA. So here this TH1 will be either -6 or we need to load FA into the TH1. Okay, and after that, to set the SCON register, here what we need to do, the upper 2 bits of the SCON registers are mode 0 and mode 1, which is for mode selection. So by default we need to take mode 1, okay, because it is variable baud rate. So mode 1 SM2 bit will be 0, receive enable will be, either you can keep it as 0 or 1. Okay. So these bits are 0, then the remaining bits are TB8, RB8 00, TI and RI 00. So here the count will be 40H. Okay, that we need to load into the SCON register. Okay, so here we have taken the initial setting. Now we will move, or we will write the program here. So first instruction will be hash include reg51.h. Hash include reg51.h. 8051.h. After that, what we need to do? We need to set, or we need to write the program, a void main. Very same as that of C programming. So first void main. Now here we need to write the count, whatever which we have set for tmod, th1 and scon. So here we need to write tmod equal to 0x20. Now see here, whenever we are representing any hex number, either we can represent that by just by giving 20 with the abbreviation h, or we can write it as 0x20. So when we are writing it as 0x20, it means it is the hex number. Similarly, for th1, what we have said, 0xfa. Now see here, I am not writing it as 0fa directly, I am writing as fa. Why? Because I am representing it in terms of 0x, the hex number. When we are writing it as fah, in that case, here we need to write 0 before the character. Okay, so here we need to represent it with 0xfa. Then scon, the value which we have loaded in the scon is 0x40. Okay, and after that we will start the timer by making tr1 equal to 1. Okay, this is a simple case. Now here, when we have started the timer, the data should get transmitted from S buffer. Okay, so here what we need to do, we need to keep the infinite loop with while. Here I am writing while in the infinite loop, the value which is in the S buff will be equal to, I am giving some sort of character. Okay, let's say I am giving the character as A. And when this data will get transmitted, sorry, just a minute. S buff, we need to write it as capital letters because this is the special function registers. Okay. Now after this S buff, here the data will get transmitted unless and until the TI bit is set. So we need to check the status of TI bit. It will be TI equal to 0. So unless and until it becomes TI is not getting set, it will remain in the loop here only. And after that, when the TI is set, we need to clear TI. So here in this program, what we have done, here we have set the value for tmod, th1 and scon, and after setting the value, only we have transmitted the data into the S buffer. Okay. So when the TR1 is set, the S buffer will get full with the value, okay, which is getting transmitted, and when the data is getting transmitted, the TI bit will set. Okay, so this is the program. Now we will run this program into the kill. Okay. Now before setting the kill here, keep in mind, I'm closing this project. So when we are writing the program for embedded C, here what we need to do, we need to create the new project. Not why? Because the previous programs we have done in a assembly language. So here for embedded C, here I'm giving the name test1C, okay, project. Then after that we need to select the chip. So here I'm selecting 89C51. Now see here, copy standard 8051 startup codes to project folder. Now previously also I have told you that when we are writing the program in embedded C, assembly language, we need not require to add the startup codes. But if we are writing the program in embedded C, we need to add the startup codes into the project file, because these are the attributes which are required for embedded C programming. Okay. So why it is required? Because just like when we are writing this embedded C program, C programming, here we are including the header files like stdio.h or conio.h into the embedded C program. Similarly, to identify the functions and the features of 89C51, here the standard header file reg51.h we need to add into the main program. Okay, so for that purpose, we need to add the startup A51 into the when we are writing the program in embedded C. Okay. So here we are taking the program into embedded C, okay, or kill, and we will save this program with the extension CRI serial character. I am taking it as serial character dot C. Now see here in the embedded C programming, we need to save the program with dot C extension. Okay. Now see, this program is added. Now we will add this program into the project file. Serial character dot C. Okay, add and close. Now we will build the program. No, there is some error. We need to use the return value. So void file, and here it will be file. Void main missing function prototype. This uppercase and lowercase case, these are making the problem. Now see here, there are 0 errors. Now we will run the program. Okay. Okay. Now see here, while running, writing the program, running the program. Here you need to open the serial window UART1. So this window is open here. Okay. Now when I'm running the program, see here. See here, the character A is getting transmitted. Okay, and it is for infinite loop, because here in the program we have kept it in the infinite loop. Okay, everyone understood it? Are there any queries in this program? Okay, so this is for transmitting the single character. Now we will modify the same program in such a way that if we want to transmit a complete character string, then what we need to do? Okay, so I'm taking another file. I'm writing the same program here, void main. Now here what we will do, here in this program we will specify the character string. So in spite of transmitting only a character A, if I want to transmit a complete string of some few numbers, okay, for example, let's say assume I want to transmit KIT Kolhapur, okay, serially, then in that case here what we need to do, we need to specify a character. So here what I will do, I will first specify the character. Okay, let's assume character X. I'm giving one character. I'm defining one character. After that, I'm again defining a character string. Okay, so character, I'm giving some name Z. Okay, with the string of 50 numbers. Okay, let's assume. Okay, that means it will reserve the 50 locations. And here I'm writing KIT space KOLHAPUR, Kolhapur. Okay, in double inverted comma. So here I'm giving a string. Now here just like the previous program also, we need to set the tmod, then th1, scon, and we need to start the timer. Okay, now after starting the timer, here what we need to do, we need to transmit this KIT Kolhapur a string. Okay, but this string is of 50 numbers. So here what will happen? Complete 50 spaces will get transmitted. So here for that purpose we have taken one character as X. Now here what we'll do? We'll remove this while. Okay. Now here I'm giving a loop for X equal to 0, X less than, how many characters are required here or spaces required? 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so I'm taking here 13 because there should be some space in between Kolhapur and after the next string. Okay, then X plus plus. In this for loop, here what we need to do? The S buffer value will be here the character string Z. So I'm writing it as Z. And we will check it unless and until this TI becomes 0, the complete string will get transmitted. Okay, and once and after that, once TI is set, we need to clear the TI and again we need to repeat the process. Okay, so here I will save this program with string.c. We will add this program into the source group and we will check what will happen. String.c. Syntax error. Z. Oh, so here it is Z. Okay, so here what we have done, unless and until this X becomes 13 or this character becomes 13 here, the data will get transmitted to the S buffer. Okay, so we will check this program. Now see here. Okay, so all time this KIT Kolhapur is getting transmitted. And so if assume here in the same program, what I will do, I will just make some modifications. So in spite of writing 13 here, okay, these are the number of characters here, I will make it as 10. Now we will check what will happen. See here, so only this KIT KOLHAP, okay, that much of only characters are getting transmitted. Why? Because here we have kept the limit with 10. That means only 10 characters from this string will get transmitted. Okay, so if we increase it as 14 or 15, then what will happen? It will show some spaces, and after that, here the next data will get transmitted. Okay, that means again the KIT Kolhapur will get transmitted. Now see here. Here in between this, after this KIT Kolhapur, there is too much space. This is too much space is because of here more characters or more spaces are included into the program. Okay. So depending upon the spaces required, we can adjust it. So this is for transmitting the string through the serial communication. Okay, so here we can check the data in the S buffer. Okay, everyone understood it? No, Aishwarya, Omkar. What is your problem? Omkar, Aishwarya? Okay, where is Omkar? Where is Aishwarya?
Sir, I'm there.
Hmm?
Omkar, I'm present.
हाँ ओंकार, क्यूरी का है?
No, sir.
Okay. Have you understood the program completely?
Yes.
Okay. Now see here. In the same program, we will do the modification. Now just tell me one thing. Everyone is my kill screen is visible to everyone? Is there any issues about the characters, or should I need to increase the font? Okay, now see here in this program here, what we have done, we have transmitted a complete string uh, to the buffer. Okay, now what we will do, we will limit the same transmission of the string unless and until if any switch is pressed. Okay, or when any switch is pressed, then the complete string will get transmitted. Otherwise, the string will not get transmitted. Okay, so this will be the modification we are going to do into the next program. Okay, so here what we will do, the same program we will take. Okay, and we will save it with string switch. String switch.c. Okay. Now see here, what we are doing, we are going to do, if suppose any switch or any port pin is pressed, then and then only the data will get transmitted, otherwise the data will not get transmitted. Okay, that is a simple program. Okay. So here, what we need to do, we need to specify a port pin for a switch. Okay, or we need to specify that particular port pin as a switch. So here what we will do, we will define as bit. Okay, S bit is a bit variable which we are using into the embedded C. Okay, so this S bit we will define as SW. Okay, with port 2.0. Okay. That will be the switch which we are going to define. Now in the same program, here we have defined everything, character and etc etc etc. So here what we'll do, we will give the condition. Okay. So when the TR1 becomes 0, here or TR1 is set, here what we'll check, if we will provide the condition if, which condition, SW equal to 0, or you can make it as 1 also. Okay, but when we are making it as 1, before that we need to clear the switch. Okay, so you need to define it because here when we are resetting the microcontroller, every port pin is in the input mode, so every port pin becomes 1. Okay, so it is the input mode. So here what we need to do, we need to specify the particular port pin or we need to clear that port pin, and after that we can make it as 1. Okay, so here what we will do, we will keep SW equal to 0. So when SW equal is 0, so here when SW equal to 0, then the complete data will get transmitted. And if suppose this pin is 1, then the data will not get transmitted. Okay, so this is only one condition. If the switch is 0, then the data will get transmitted. If suppose we want to make two conditions, then also we can do it separately. Okay, so we will check it this program, and after that we will move that, or we will check that program. Okay, so it is string switch. No, so here I will add this file. String switch add 0 errors. Okay. Now see here in this program, what is the condition? If suppose the port 2.0 pin is 0, then and then only the data will get transmitted. Otherwise, the data will not get transmitted, or the data transmission will get stopped. Okay. So here I will open port 2.0. here, and I will run the program. Now see here, the data is not getting transmitted. When I'm making this port 2.0 pin as 0, the data is getting transmitted. Okay, and when I again write it as 1, the data transmission is stopped. Okay, everyone understood it? So in the simple process here, what we have done, we have only provided a switch. When the switch is pressed, then the data will get transmitted. If the switch is released, then the data will get stopped, or the data transmission will get stopped. Okay. Now, in the same program, we will add one more condition, that here, if the switch is 0, this data will get transmitted. If suppose the switch is 1, then next data will get transmitted. So here we will define it as character. I'm writing it as Y. I'm providing the space equal to department of etc. Okay, this is one more character string. Okay. And here what we will do, the same process. If this is SW equal to 0, then this data will get transmitted. Otherwise, here what will happen, if the switch is not pressed, then the department of ENTC, that data will get transmitted. Okay, so here the same program here, we will write here as if SW equal to 0, this loop we will take or copy, and here we will provide else. Now here, how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here we will keep this 12. Syntax error near else. Here we need to provide y. Equal to 0, 0, 4x equal to 0, 3. Okay, so here we have done taken two conditions. If SW equal to 0, then the KD Kolhapur will get transmitted. If SW is 1, or that switch is 1, then department of ENTC will get transmitted. Okay, I'm running the program. Now see, department of ENTC is getting transmitted. When I press the switch, then see here KD Kolhapur is getting transmitted. Again, when I press the switch, department of ENTC is getting transmitted. Okay. So everyone understood it? What we have done? Is there any query? Okay, now see here in this program, here we have done one program for transmitting only a single character. After that, we have done another program where we have transmitted a complete string. The third program in which when any switch is pressed, then and then only the data will get transmitted. And after that, we have done the program for with two conditions. If suppose the switch is pressed, one data will get transmitted. If the switch is released, another data will get transmitted, and so on. Okay. At the same time, here we can take two switches also, and we can do the same program for transmission of data. Okay. During the reception also, here the same process will be done. Okay. But for the reception, we need to enable the receive enable pin, and whatever the data which is getting received, that data will get stored into the memory location. Okay. So whatever the data which is received at the S buffer, that will get transmitted to the particular memory location. Okay. So this is all about this serial port programming. Are there any queries?